Okay, my name is Ben. I'm here to talk about hacking smart cards. Hacking in a way, not tracking. I'm using smart cards. I'd like to give a short introduction to smart cards. I can barely say nothing about cracking smart cards, but I can give some references of people who did that and who found the papers for it. But you won't leave this talk with knowledge about the correct ATD or ATD. So it's kind of the same. This is not pictures motivation. This is David Rees from the University of Michigan, and this very thing he does with smart cards is emptying vending machines with screens. Very nice picture. Unfortunately, in my university, they don't have these machines, but I wish they had. Okay, what are smart cards? Smart cards are basically, you know, all these random cards we might have. They come in different forms, usually a plastic card, but if we want to look at the ingredients at the chip, it could also be some different form like this Java button over there, or USB codes. Here are some of them. Basically, a smart card is a small computer without input-output system. So there's no keyboard, there's no monitor, that's the part you need to have to solve. But it has a RAM, it has an EEPROM, maybe a ROM, it has a CPU, maybe a crypto code processor, and usually it's run some kind of operating system. Some cards are not really smart, they are dumb. Everybody in Germany knows these cards we have from your health insurance. That's only a memory card. It has your name and your address on it. And I think they can change that data with the password, but you can't do anything else with that card. Also, there are very, very stupid cards that only have a few bits. All you can do is read the number of bits, set to 1 or set to 0, and change them. Usually only the one way. You can use that card as some kind of tokens for washing machine or whatever. That's not smart in the way I see it, but actually some definition that they also count as smart cards. There are different types of smart cards. People in Europe might know the GSM smart cards with the GSM mobile phone system. They are very specialized for that application. They are more generic smart cards like Java cards that came up in the 97 hype, maybe about 97. Let's do everything in Java, let's program smart cards in Java. You can do some stuff in Java with them if you want to put the application on it. That's the way to go. And this talk is mostly about the crypto cards. That's some smart cards with a crypto coprocessor, and the ones where you don't need to write a Java applet to access that hardware, but where the company already published a set of commands so you can directly access them. I'm talking about the details, what you can do with smart cards and stuff. Here's an example of if you want to use smart cards, you have some readers. I have here some of them. And, once you plug in the smart card, the first thing you get, if you have some software talking to the reader, the so-called RS2 that is some strange byte sequence like this one, and it has lots of metadata. The most important, it's most important as an identifier because that metadata usually is unique, so you know which type of smart card you have and what you can do with it. And you can at least use that string, search in Google, to find a name, and then you can find for the data sheet or whatever state logo or whatever. Oh, convention, sorry. identification string you can use for mostly a book. Big books with the details on the identification string, so you can look up all the values and what they are. Usually it's whether what kind of protocol the smart card is talking. Most of them are talking the T0 protocol. The better cards are also talking T1 protocol, and all these values are mostly timing values and stuff like that. That tell you how fast you can talk to the smart card, or whether other protocols are available. This is the first thing you get if you talk to some smart card. And the next thing you can do is to use a mechanism called protocol type selection. You can select the protocol you want to talk to the smart card, and using that, for example, increase the speed, you want to faster quickly, all that stuff. The nice thing with encrypted tokens is you don't need to do that. So I'm mostly using modern smart cards and new protocols available to modern smart cards. So there's a lot of garbage you should know if you're using a private cloud to these smart cards. But new stuff, it's not very important. Also, it's usually always this stuff is very low level, handled by the provider. If you want to provide a provider for smart readers, you need to implement all the stuff, all the protocols. But if you already have a provider, you know the details. It's not that it's identification. Most of the stuff is timing. The values for T1 is stuff like what's the maximum size of a packet I can send to the smart card. I guess most of you know TCP, and Ethernet, and all that, and you have some extra plans. And this is a very, very simple protocol. And the smart card somewhere in this script says the maximum packet size I can accept is FE, that's the TAH model. I can send to that card 245 bytes in one packet. The real thing you do when you write smart card applications, you use application protocol data units. So these kind of packets you send to the smart card, 30 bytes of class and instruction. The small ones, the command, identifies the command. Then you have 2 bytes for parameters. And you have to look up into some document what they are, so you accept them. And then there's a length encoding, and according to the LC byte, you can send that many bytes, and then with the LE byte, you can specify how many bytes you expect as an answer. The whole problem is that lots of these bytes in the end are optional, so it's a class 4 command if you have data you send, and the smart card also sends data back. If you only send data, I think it's class 3. If you only expect data back, but you don't send data, it's class 2, and so on. It's quite complicated. There's a standard on smart cards. It's ISO 7860. The standard has 10 or even more parts of it, and if you hear a new part of that. The first two standards is stuff like what's the size of the card, also the size of the needs, credit cards, and all that stuff is standardized in that ISO standard. Parts 3 and 4, for example, the connector fields for the smart cards and the basic commands you can send to the cards. The problem is the standardization stopped with very few commands, and all of the smart cards vendors added more and more commands, for example, crypto commands. And now we have a standard, I think it's part 9, that has these crypto commands, but nobody implements them. So every time you have a different smart card, you need a handbook of the smart card manual, but you can do it very much. Most smart is always the smart card has a fixed size of each ROM, maybe 8 or 16 or 32 kilobytes, and whatever objects you create in that file system, you create it with a fixed size value, so you need to know in advance how many bytes you will write into that file, that object, or that key, or whatever. That's not very convenient. The game or the folders or file names, simply 2 bytes. 3F00 is the main folder on all smart cards, and then you can put some object into that main folder, or create subdirectories and put objects to the subdirectories, but that usually is limited. So somewhere in the smart card menu you will see maybe 5 levels of subdirectories, and that's it. This is an example for so-called PKC 15 compiler smart card. That's a standard for cryptographic, standard for cryptographic smart cards, how you can put keys and certificates and stuff like that on the smart card. And if you have such a card for verified 2F00 and a subfolder 5515 with usually these files in it, and some more. The problem is don't expect any smart card when you sell the card that was selling some solutions, actually compiler to the standard. I know one company that does, and everybody else usually does not. Also with subdirectories, but not with files, you can add an optional application ID. It could be some string or some hex byte or whatever the smart card specifies. The only application I ever saw that is the AKS string from a company that was the name is Elevated Knowledge System, so it's English. File systems also maybe don't expect a Linux file system where you can do anything. It's not only limited to the size of the file, also the type is limited. And for example, okay, and we have different types of files, and they're handled by the smart card. For example, you can add a fixed record to the file usually. So you can say, okay, this file will have 20 bytes record, 15 of them, and the smart card will manage for you which is the current record. Either you can only add these records, or you can have a secret file. So whenever you add a new record or overwrite a record, you will overwrite the next one. This, for example, using payment applications. You simply have a secret record log file for the last maybe 10 or 20 transactions. You can have raw files, simply put binary in it, get binary out of it. You can have tag value files, so you can put data to it with a tag byte, a length byte, and then that amount of bytes. And the whole system can be a bit hierarchical construct, but I don't see a big advantage over using a raw file and reading everything from it. The main advantage for that is you can only read some of the bytes, and that's important as smart cards, and most of the communication with the smart card can be very, very slow. But newer smart cards are quite fast, and if you have a fast reader, it's usually no longer a problem. Smart cards have security features, like you can put APIs on it, and some of them can download encryption, decryption, dash, cache things for you, whatever you want. I've had the most interesting stuff to put APIs on them and then boost them. And one of the nice security features is unless you specify at the time you put the key on it or you create the key on the smart card, these keys are not exportable. If you have a micro chip lab and open the smart card and maybe read it, but there's no way, at least in the vendor page, there's no way to extract the key. We usually have PIN codes, or it could be a password, and some smart cards may only support alphanumeric characters, some only numbers, some bytes, whatever you put into them. This is usually limited by length and stuff. You need to be smart to read them. And these PIN can have a counter, usually have a counter on them. You have so many tries to guess the PIN. And the nice thing is the PIN checking is done by a smart card. And you have a security model where you need to get the PIN first to access the S8 key. And except very old, stupid implementations, it's done in a secret way. So they first decrease the counter, then check whether the PIN matches, and then maybe again increase the counter. But if you try the PIN too often, it's blocked, and you no longer can. There's no way to access that smart card. So simply brute force attacks will not work. There were some very stupid old implementations where they first tested the PIN first, and then decreased the counter. And if you gave the card not enough energy to write into the memory store where it was supposed to write in the new value, it didn't work. So you could try all the passwords and suddenly you got the right answer, or the card tried to get more energy and you do, okay, it's the wrong password. Then you can have several pins on these smart cards. You can have user pins, and there's usually a special pin, a security officer pin, and that is used to create the normal user pin and manage things. What exactly is every time? There's no standard when we need one of them, both of them, but the usual convention is we use the security officer pin to create the structure, the certificates, the keys, and all of that, but only the user can use them. So the security officer is often blocked out, you cannot try to use the transport key below is special with some smart cards. You use counter this transport key and the company tells you what it is, because you can't use the smart card without it. And usually special commands like format that will erase the whole smart card and everything on it are protected by the transport key. With some vendors, the transport is limited to 3 tries, so give the wrong key 3 times and you can throw the card into the trash. Other card operation systems like the Siemens card OS and 4 have several special keys that start with backflow key and make personalization key. Start key is more or less the same as for the erase command and some special commands. I'm avoiding a bit about the package load key because smart card operating system where you can put a binary on it, and if you have the package load key, you can ask the operating system to start that binary, and so you can add the software. So I wonder if they don't tell me what the package load key is, but they know there is. I know there is some. So if someone finds one of my smart cards with the card OS 4, and yes, you can get the vendor to incorporate. They could add some software, start that software, and maybe that software can access my keys. So I'm a bit worried about all the smart cards and the ability to wait. People have the ability to load extra software on it and want to see the card and a very, very limited set of functionality. So I can trust it. And the last personalization is not very important. What I'm talking about is OpenSC. OpenSC is the software that most people might want to use if you have two smart cards. It's an implementation of several interfaces. The most important is the PKC50 and PKC11 interface. If you ever look at Mozilla and the properties menu and found that button certificates, manage security devices. This is it. Mozilla has the ability to load the CCC 11 module, and you can access smart cards or whatever the implementation does with an OpenSC implementation of that interface. So using Mozilla, you can access it. OpenSC has lots of tools with it, so you can look at the smart cards, look at the files, browse the files, browse the contents of the files, put data on it, change pattern, change fields, initialize the card, format the card, whatever you want. I think it's really unique that it's an implementation that supports very many cards, about 7 per state. Most development software you might see, it's a company, they have one card installed to you, and they only support their card. And some companies make it rather difficult to change from one card to another. They don't want to. They want to lock in the customers at least. That's the way I see the situation. OpenSC is not because it's an open source project, eligible license, and supports very many cards. The PTSD 11 interface is compatible, so it's easy to change the cards. So even if you have two independent implementations for the same hardware, it's really compatible. The problem is where the way the internal work is compatible. And there's a standard for PTSD 15. It's the file system standard for the smart. It's a first implementation. Put these files into that directory, create some index files, maintain the index file, and so on. And most smart compilers don't implement this. They have their own implementation for whatever reason. And thus, for example, the Siemens CardOS M4 all devices have one from Itron and one from Allied here. They both have the same Siemens CardOS M4 thing, but both companies have very different implementation. They put the files into the different directories, so the implementation are not compatible. And OpenSC is implementing the standard, but because it does that as a third directory, and if you try to use that with all implementation, 3 different directories, 3 different keys, 3 different pins. This will still work, but the first key with the first implementation, the second key with the second implementation, and so on. A few words about smart card readers. The normal smart cards have this, the plastic cards that 6 or 8 counters. If you know what smart card is in, you need some kind of reader, like demo hardware over here. Most companies offer some driver for it, and many companies offer drivers for Linux too. There are two very common driver formats. The first is the so-called CP80 driver, and that standard was developed in Germany for the German health insurance card. And it's a standard written for DOS applications, a small shared library or whatever, with 3 functions. Init, standard command, and standard 3 functions. And it's not written for multi-user operating system or anything. And it's very simple and still in use. OpenSC supports driver of that standard directory, but I do not recommend using it in production because OpenSC will that way need to directly talk with the hardware, for example, the serial device. And if you have more than one program running and both try to use the serial device, it won't work. Use some other implementation, some other way. Usually has a middleware that takes care which users are allowed to access the smart card. And if one user uses the smart card, it will lock down and not allow any other user to access the smart card and all the security stuff. The second interface for drivers for readers in the IP network. There's a standard called PCSC, it's a working group, and that interface or that working group defined the standard most used on Windows. But it's very, very popular even on Mac OS X and Linux because of the implementation called PCSC Lite by David Corpora, and it's an open source application. Well, it's under BSD4 license, so you know it's that open enough, good enough for people, and it comes with full source code and free of charge. And yeah. But that standard is also not very, very nice. If you ever implemented a driver for it, it's some kind of vendor standard. So there's tons of things everybody needs to do again and again and again in every new driver, because the standard is too high level on the reader side, and also might be, I don't think it's really nice to use. And third applications, sometimes the drivers for readers are directly integrated into some applications. Especially you will find lots of smart hard projects, but I think some of them are already dead for some years. It's mostly a demo application, one special card, one special reader, and one thing you can do, for example, the login or whatever. But most of these projects never got to the stage where they support several different cards and several readers and all the flexibility and maybe several operating systems. So, yeah. One thing we support with OpenSC also helps in a small list here. The first four are smart cards, the Gemblus I think. They have these public key cards, there are lots of other cards, but if you want to use smart cards, go to the DK, and then 8 or 16 is simply the size of the RAM. 8 kilobytes or 16 kilobytes. Similar to Schlumberger Cryptoflex cards, one of the cheap cards available. They're very nice to use, and the manual is available on the net, and it's documenting all that stuff. The only problem is I heard that the company actually closed the smart card development team or whatever, so you can still buy these cards because it doesn't look like anyone will improve the cards by adding these kind of things. Third is the Dealer's Connect card by the company part of the German Telekom. Actually, they claim you can buy it as a key point, the local telecom office. I'm still trying for about a month, and maybe I'll be able to buy one of the cards. And all the next should be Star Cosmos, Star it's a variant of lots of other, the others are USB tokens like this one. Also supported is the national ID cards. I think Sweden has one, Finland has one, Estonia has one, and Belgium is going to get one. One of the company that is going to develop part of the solution for Belgium is actually working on the SC42. So these cards are working. I don't think the German identification cards are working. The problem is that Germany has created its own solution, its own definition how a smart card should look like and what objects and where to place them and all that stuff, and the result is very, very complex and very difficult to implement, and it's not standard. So you need to duplicate the whole effort if you want to support that. If you want to use OpenSC, I think that's a bit difficult. You need OpenSC, obviously, and then there are several drivers you can use on middleware. Most common is the PCSC Lite middleware, and you need some RTN driver. I wrote some drivers for PCSC Lite, but the interface is not very nice, and you need to implement many things right for any driver. wrote a new implementation called USB tokens. It's only for these USB tokens, and I think 100 extra lines of code as could support the second, and another 50 lines of third device and so on. And so it was quite simple to replace the whole big fat, at least big PCA slide implementation. I think the source code is 1 megabyte compressed, something like that. A few hundred lines. If you find your own interface and don't use that interface created by some community of companies. That USB token is obsolete, please don't use it. Duplicate it, it's still hybrid, it's still supported, but please don't use it. The better thing is OpenCP, that's a new implementation. It does the same thing as PCSLI, it's a middleware, but it's also the same thing as the IP network. It implements several drivers, and it's quite easy to add a new driver because it has some smart card that either is not supported by any project. OpenCP might be a good way to implement a driver because usually it's 100 or few hundred lines of code. And you can use all the infrastructure because all these protocols are already implemented. And the last thing is the CPA interface. Yeah, you can use it. I don't recommend it. At least not if you want several processes accessing the smart card, or even several users be able to access the smart card. That will work very well. What you can do with smart cards, or my big agenda is to get rid of passwords completely. I don't think passwords are a good idea. There's lots of problems with passwords. I think certificates, public keys, and all that are solutions. So the first thing you can do is use this as an H and have your secret key on the account. And it will not leave the account. It will simply SH will ask for the crypto operation, whatever size and data or whatever it does. You cannot please do that for me, and it works. Also, you can log in smarter, you can use Mozilla, Netscape, mail sign, subscription. You can access website protections where you need to have a kind certificate, authentication. You can add that certificate on the smartphone. Also, you can use IPsec, Respawn. If you have an X509 patch included in Respawn, I think version 1.40 was the first one that supported smart cards using here via OpenCP. Our generic modules, the common interface for accessing hardware tokens, smart cards, crypto devices, whatever, is the PTC 11 engine, and it's the biggest part of the OpenSC that engine. So if you have a project that already uses that interface, you can simply plug in the OpenSC shared object and it will work. If you're using OpenSSL in some projects, whatever, we have the engine for OpenSSL, and for example, some of you might use the OpenSSL record command to create a certificate request or even a server-side certificate. Simply add one extra command ahead of that. Please use that engine, load that engine, and then you say in the record command the key is maybe 45, the engine is OpenSC, and the key form is engine, so it will not try to load the key from the file system but from the engine, and it will work. Not all commands of OpenSSL are currently supported because the OpenSSL implementation didn't do that. Somebody added support for the S-client command as a client connection, client part of the SSL connection. He added support for the OpenSSL yesterday or 3 days ago. Shouldn't be hard. And if you're using SSL as a library for some in your application, I don't know how much code it is, but I guess 10 or 20 lines of code and you can use smart cards. Okay. Using OpenCP and SC and all that stuff, it's an easy download files and configure them, install, and for the setting for OpenCT, you need to specify the path to the first one or to CCC Lite, and you need to enable out. And this turned out to be what I really want to do is a workshop, and this is some examples of what I really want to do is a workshop where I about smart cards and readers and USB tokens and whatever about friendly people who work with me. So later we can go over to the hack camp, and if you want to try it, whether you like it or not, partner with me. But I have a list posted on the info counter. If you vote your name to the list in the first 20 slot, then I have some hardware for you to try and use. If not, we will see first come first serve. Sorry. Configuring the OpenCT on Fusion topic. You need to create some directory, set up an init script, and yes, most people know how to do that. There's an example, you can copy it. We have the configuration file that you might want to change. But it's quite simple for fewer devices in the end. There's 4 lines. The difficult is the hot plugging mechanism of Linux. Linux supports hot plugging, so I can add this USB token, plug it into my machine, and Linux will run one command. And we want to use that facility to run drivers on demand. All the drivers are user-space drivers. You don't need to make a kernel or whatever. All these drivers talk to the serial device or USB device files. The hot plugging is about running such a user-space driver as a small program, and set up with the distribution sometimes. The kernel calls the program /hotplug. That does not exist. We have an example hotplug. You can simply copy it to that file and it will work. But if your distribution already includes that program, some kind of multiplexer, it will look what kind of hardware is new, and then we'll look into some file tables and see what program to start. So the configuration might be a bit difficult, and it might be different on every Linux distribution. Sorry, I didn't do that, but we have documentation how to do it, at least for the standard cases. Okay, I can do some demonstration all the way to the top. Too much, I think. It's working? I will give a short demo how to initialize cards, how to use OpenSSH, Zora, and all that. I think I hope you're interested in that. And after the demonstration, whatever, we can move over to the workshop in the hack camp and hack with hardware. So. I already compiled the software. It's exactly the software you can download, and I already configured it. One of the technique, and that's the identification string. If you want to do something with OpenCT, this will help you if that works, then OpenCT is working. Nice application is with this store application. You can go to the smart card and enter some commands like FLS. If this marker is supported, sorry, some don't do that. And you can look at the access control lists, change directories, and all that stuff. And as an income out, import things like verify to and pin and but it's mostly low level. This is like what's really hard. The tool command has lots of things. It really function mostly the same, like show me the RPR, show me the number of readers. Here we have reader. Or if you want show all files in the documents marker and all the content of the files except for private keys, you cannot display that. It was get to mark. But usually you will have it back now. First thing you will need to do is run the EKC15 init command. It will create the structure, the EKC15 structure. And you can get a security officer in on smart cards that support one. And if you want also an unlocking code, it's quite useful. Not every smart card has a format command. And if you forget the security officer and stuff, you cannot unlock and throw it away. Okay, first thing is you need to create the structure. And usually you want to create a pin for the user. This is my key and ID 601. Then you might want to store a certificate you already had, right? You want to copy, qualified, and I want user 01 to use it. These files usually protected by hashtag. Oh, sorry. Yeah, it's got the device you're currently using is an Aladdin e-code code. And you have that hardware operating system convenience and Infineon chip and whatever. And it has one special limitation I have not seen in any other card. You can create keys on it or store keys on it. And you can assign a usage on the keys, what you can do with the key. And this smart card does not allow you to create a key that you can use both for signing and for decrypting emails. But usually, if you get buy a certificate from Forti or whatever company gives you an SSR certificate, you usually have only one key for both operations and not two separate RSA keys. So what we did was implemented a special hack split key to store the same key twice, once for signing, once for decryption, and then choose the right one. Okay, I think everybody knows edit and preferences, and there's the privacy and security stuff, and it has things called certificates. And what you do is manage security devices. Okay, and if you have loaded it. Look that way. Oh, sorry. And all you need to do is load the device. window. You simply enter some identification string, whatever you prefer, specify a file name to the OpenSC PKC 11 file, so-called, say OK, and after a few seconds, yeah, it has been ended. And then you can vote the manage certificate button. And now you will ask to enter the password for that button. I want to have and yeah, you will see the certificate stored in the button. And you can use the normal email client to sign and encrypt it. What you also can do is SSH. You can download the public part in the format SSH accept of the certificate. You can download that part, put it into the file, transfer it to the public machine, and it will then authorize the keys file and the .sh subdirectory. And part of that, you can use SSH to connect to that machine using the smart cards. You need to specify the parameter, reader device, -0, and that's it. And enter the PIN for the smart card if you have the PIN on the key. And yeah, that's right. You can also use the same thing with the SSH agent. You can use the OpenSL string. I don't have time to demo it, but since one command you to enter the OpenSL shell first, some documentation. And yeah, the panel modules are also working. You can download the signature of the key, put it into some file called .eid, get directory, and then authorize keys. And all the keys in that file will allow you who have ever had that key to log into the system, which is smart card, and to pay for the smart card. Okay. Questions so far? Some resources, if you want to read more about smart cards, the first one is a handbook of a chip card, and it's also available in English. For general security, the Anderson security engineering is quite good. And if you want to know more about cracking smart cards and what you can do with smart cards and all that stuff, this guy Marcus D. Kuhn has some papers on it. And, one of the things you can read is there's some equipment weighing $500,000 and I think it's in most universities, and every student with access to that equipment and having a time and some basic books should be able to read everything from the smart card, most smart cards. So I don't think they are very secure or not as secure as the companies claim they are. Definitely not unbreakable, but equipment worth $500,000 is good enough.
Okay, what is the performance of such a smart card? Like if you used such a card with the OpenSSL in order to store an SSL server key, would it give usable performance to use this as an SSL server?
Don't do that. That would be slow. Key generation, if it works, it takes about 40 seconds on some smart cards, usually on the newer one, or even less of that. Up to 40 seconds on old ones, and using the smart card is a few seconds overhead. I think that there's room for optimization even in the software. We could add some kind of proxy already with the proxy concept, but still we will not have more than 1 or 2 connection seconds. Other questions? Okay, I hope you enjoyed the talk, and everybody who signed up on the list and wants to pay smart cards, maybe we can go to the hacktivism center. But I'd like to thank Jim Rees and Aladdin Knowledge System. They implemented the hardware so we can play with it. Thanks to Jim Rees from the University of Michigan and to Aladdin Knowledge System.